Whoa! Hey guys. Don't worry, I'm not going to have the webcam up for the entire time, but I wanted to show you a demonstration, so I figured, why not? Obviously, I've just really been wanting to get you guys to go back and watch clips of the Sochi Olympics, because it kept coming up in the last video, and sure enough, here it is again. So, you're welcome. Go back and watch some downhill skiing or speed skating or something like that. But let's keep going with Objective 38 here. So now we're going to talk about the surface area of cylinders. So remember, we've been thinking about this difference between volume and surface area, filling and wrapping. Filling a solid, wrapping a solid. So we're going to go to surface area here. Now, that's exactly what we want to think about. Surface area, think about, remember, wrapping the present. How much do you need to cover every surface? That's what's important. But we're specifically going to talk about cylinders. So to calculate surface area, we're going to add up all the areas that create the figure. So we want to think to ourselves, well, what shapes create a cylinder? What's the top? What's the bottom? What's in the middle? And this is really where this comes into play. So I'm going to show you what we call a net. So again, I got a can here. So watch. I got a can of beans. Okay, got a can of beans. So when we think about, well, if we needed to wrap this, right? Like if I was going to give you a present, obviously I would give you a can of beans. So if I were to give someone a can of beans and I want to make it look nice and wrap it and put a bow on it, well, I got to figure out what's the total area that I got to cover. So naturally, we know a cylinder. We're very familiar with cylinders. So on the top is a circle. Boom. We know directly across from it on the bottom is a circle. But the question is, what's this curved surface in between? And it's a little deceiving because it's not really a curved surface. Well, it is, but it's really just a regular shape that gets wrapped around to connect the two circles. And if you think about, and the reason I have this can of beans is that the label, if you were to take the label and remove it from the can, really, hopefully some of us know this, is that it's really just a rectangle. So all it is a rectangle that gets wrapped, and now it has curve to it, but it really just starts out as a plain old rectangle. So that's what we got here. So we got on top, bottom, rectangle in the middle. Oh my gosh, 130 calories per serving. Okay, so I'm gonna sign off, but we'll keep going with this. If I can find it. Where's my cursor? There it is. All right, peace out. Okay, so we know that there's a circle on the top, circle on the bottom, and a rectangle in the middle. So this is what we call a net. And a net is just a 2D depiction, a two-dimensional depiction of a three-dimensional object. And, you know, I want you to be familiar with that word. So if you hear a net of a shape or of a solid, you're going to know what it means. So really what this means is that, here we go. We're going to draw a circle to represent the top, a circle to represent the bottom, and then a rectangle that represents the label in between. And a lot of times you'll see a net drawn like this. You take the top over here, then you take the middle, because that's our label, our can of beans label, and then this is the bottom of the can, of the cylinder. So remember what we said, guys. What we said is that we need to find the total area of all the surfaces. Well, we know, right? We know that the area of a circle is pi r squared, that's the top, and the area of a circle is pi r squared, that's the bottom. Now the middle, if you think about it, the middle label gets wrapped around, sorry about that, it gets wrapped around the whole circle and it meets up perfectly. So technically, this length here, it's actually the circumference of a circle, the distance all the way around. So if you recall, circumference is 2 pi r, and then the only thing over here, people, is just there's some missing dimension of how tall this is. So you just times it by the height, because we know a rectangle, we need to take base times height. And if the base is the circumference of the circle that goes all the way around, then we times it by the height. So this is a net, is we take all the shapes that make up a solid and we kind of lay them out two-dimensionally. So there's our formula. Look at this. Pi r squared, that's a circle. Guess how many circles we have on a cylinder? We have 2 circles. Boom. So that's where our 2 pi r comes from. We said this comes from the idea of circumference. And then, of course, we have however tall the can is. So our height. So really, it kind of follows suit. A cylinder, if you were to wrap a cylinder, you need to wrap the label that goes around, which is 2 pi rh, and you need to wrap the circle on the top and the circle on the bottom. So there's 2 area of circles, pi r squareds. So 2 pi r h plus 2 pi r squared. All right, make sure we get this down in our notes. Now, once again, we should be ready to rock. Let's get our calculator ready. We're going to bang out 5 problems here. Bada bing, bada boom. Surface area of cylinders. Here we go. Formula, 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 formula. Find the surface area of a cylinder with a height 12 and a radius of 3.6 meters. Perfect. So, here's our formula. Surface area. 2 pi r h plus 2 pi r squared. Let's fill in what we know. Find the surface area. So we don't know that, so let's leave it. 2. Replace pi? Yes. 3.14. Replace r? Yes. Told the radius was 3.6. Replace h? Yes. Height is 12. Plus 2. Replace pi and the radius squared. Look at that. Look at that. Here's what I'm going to do. I'm going to go back. I'm going to space this out a little bit to kind of make it 2 pi r h plus 2 pi r squared. Filling in what we know, people. Using formulas. Our bread and butter. All right, so this is cool. Let's just multiply all this together. 2 times 3.14 times 3.6 times 12. Because it's all multiplication. So we get 271.296. And then here we need to make sure that we do 3.6 squared first. So this becomes 12.96 because it's 3.6 squared. Let me back this up. Oh no, I'm making a mess of things. He's making a mess. So we know in our calculator we can do 3.6 squared is 12.96 times 2 times 3.14. So this comes out to be, I'm writing in an eraser, 81.3888. So we have our rectangular piece, we have our circles piece, add them up, 271.296 plus 81.3888, 352.68. I'll cut it off there, right? And our unit is meters. And remember, guys, we talk about area. Surface area has only 2 dimensions. So it's our units squared. Okay. Use the information from the problem, plug it into the formula, rock and roll. Order of operations, that's what we do here. All right, find the exact surface area. Leave pi in your answer. We know when we talk about exact means we're going to leave pi. All right, let's take in our diagram here. What do we know? Well, we know that the whole distance across the circle is 18, so that must mean we know that the whole distance across is our diameter. But really, we know the formula only uses radius. So our radius must be half of that, which is 9. And it looks like we have a height of our cylinder here. So our height is 11.6. Hey, looks like we got what we need, so let's go do it. Surface area is 2 pi RH plus 2 pi r squared. We are finding the surface area, so we leave it. We're also going to leave pi, so leave 2, leave pi. Radius is 9, height is 11.6 plus 2, leave pi, times the radius of 9 squared. Perfect. All right, so again, right, we always kind of slide pi to the end, so multiply your numbers around the pi. So 2 times 9 times 11.6. That's 208.8. Slide your pi. Plus, we know we have to do 9 squared first, so 9 squared is 81. 81 times all the numbers around pi. So times 2 is 162. Slide the pi. So now, if we have 208.8 pi and adding it to 162 pi, then we're just like add the two numbers and then slap the pi on the end. That's all we're doing. 208.8 plus 162 gives us 370.8, and since they both had pi, we got to slap it on to the end there. So 370.8 pi are units squared, meters squared. Okay, let's keep rolling. Okay, find the exact surface area of the cylinder. Leave pi in your answer. Sweet. So, look at our diagram. The whole distance across, the diameter is 16, which means we know our radius is 8, and it looks like we're given a height of 10.3. So let's use it before we lose it. 2 pi RH plus 2 pi r squared. That's our surface area formula. Never goes out of style. So, leave pi. 2 pi. Radius is 8. Height is 10.3 plus 2. Leave pi. Radius is 8 squared. Okay, multiply. Do all your multiplying around the pi and slap it on the end. So 2 times 8 times 10.3. 164.8. Slide the pi to the end. And order of operations, we need to do exponents first. So 8 squared is 64 times 2 gives us 128. Slap the pi on the end. So now we're adding 2 pi's together. Guess what? If you take 2 pi's and you add them up, you still got pi's in the end. So 164.8 plus 128 gives us 292.8 pi units squared. We're rocking and rolling, baby. We're rocking and rolling. Okay. Now, you ever try to drink a can of beans? No. Well, maybe you do, but no. Well, how do you get into the can of beans? Well, you got to pop the top. You got to open it up. So now, once you when you pop the top of a can, you're really turning it into something slightly different. And you're turning it into a cup. Yes, a cup. Like what we drink out of. Absolutely. Everybody knows what a cup is. Because it holds the water, so it's only got one thing, a circle on the bottom, and it's open on the top. So technically, we don't need to cover that. That doesn't have any surface because it's empty. It's open, so there's no surface. So the difference between a cylinder and a cup is that, well, guess what? It doesn't have a circle here. So this is open. So there's only one circle here on the bottom. So instead of 2 pi r squareds for the top and the bottom, we only have 1 pi r squared. Only 1. So, formula for a cup, you still got the space around the middle, 2 pi RH, but instead we only have 1 pi r squared on the bottom. Because you got to get your water in your cup. You got to get your beans out of your can. Okay, so this is our new formula for a cup. So this is surface area of a cup. So make sure that gets on our notes. And let's do two problems with it. Here we go. Keep it rolling. Excuse me. A paper cup is a perfect cylinder that is 7.1 centimeters tall and 8 centimeters across. Find the total surface area of the outside of the cup, including the bottom, to the nearest unit. Okay, so if you draw ourselves just a quick diagram here, this is a cup. It's 7.1 centimeters tall, and this is important, people. It says it's 8 centimeters across. So 8 centimeters across the whole lip of the cup, or across the whole width, the mouth of the cup. Well, guess what? 8 centimeters across, that means the diameter is 8, which means we really know we can only use radius for our formula. So we want to use our radius is 4, and our height is 7.1. So let's do it. Surface area of a cup, 2 pi RH plus only 1 pi r squared. Because it's open on the top. There ain't no top that we got to cover. Okay. So we're going to use 3.14. So 2 replace pi. The radius is 4. Our height is 7.1 plus 3.14 times our radius squared. Exactly what we've been doing, except there is no second 2 in the formula. That's it. All right, here we go. 2 times 3.14 times 4 times 7.1. So this piece is 178.352. And we know we got to do 4 squared first. So 4 squared is 16 times 3.14, 50.24. Sure enough, add them up. 178.352 plus 50.24. We get 228.59. I'll cut it off at 59. Just make sure you round wherever your answers are rounded. 228.59 centimeters squared, because we're talking about area, surface area of this cup. All right, one more. Finish strong here, people. Finish strong. All right, a paper cup is a perfect cylinder that is 4.5 centimeters tall and 4 centimeters across. Find the total surface area of the cup, everything on the outside, including the bottom. Let's do it. So the height is 4.5, seeing that it is 4.5 centimeters tall, and it's 4 centimeters across the whole cup, means its diameter is 4, meaning our radius must be 2. To the formula, 2 pi RH plus pi r squared, because it's a cup. That's important. It's a cup. Only the bottom, no top. 2 times 3.14 times the radius of 2 times the height of 4.5 plus 3.14 times the radius of 2 squared. Plugging in numbers, spitting out surface areas. That's how we do it here, folks. 2 times 3.14 times 2 times 4.5. 56.52. And we got to do 2 squared first is 4 times 3.14, 12.56. Add them up. Nice and tidy. 69.08 units squared. Okay, so we need to make sure we have these two formulas. Whoop, wrong way. We got to make sure we have our two formulas. Formula for surface area of the cylinder, and if we cut out the top because we got a drink out of the cup, we slightly change our formula and drop that second 2. All right, so surface area of cylinders and cups. Once again, go back and watch some highlights. Clearly, I'm trying to advertise the Olympics that are now 6 years old. So there you go. Go have fun. I don't know. Look up something cool. Speed skating, that's always a good one. Downhill skiing. giant slalom, hockey too, but oh, those ski jumps too. Oh my god, those people fly. Go look up some of that stuff. Sochi 2014. Peace out.